Could this be proof we're not alone, or just an ordinary comet? What NASA just released might surprise you. For weeks, the astronomy community, the online world, and basically anyone who loves cosmic mysteries has been waiting for NASA to finally break its silence. Not because the agency usually hides things, but because this time, the silence wasn't really their choice at all. One question started spreading everywhere. What happened to the new 3-eye Atlas images? Were they real? Why were they delayed? And more importantly, what exactly did NASA discover? The moment the press briefing began on November 19th, 2025, it felt like everyone was tuned in. Scientists, journalists, space nerds, conspiracy creators, skeptics, everybody wanted answers because 3-eye Atlas isn't just any comet. It's only the third known interstellar object ever seen passing through our solar system. That already makes it rare. But it wasn't the rarity alone that made people impatient. It was the endless online rumors suggesting NASA had found something strange, something metallic, something that didn't behave like a comet, something that could, at least according to some viral videos, be artificial. NASA clearly knew what people were thinking, because the very first thing they addressed was the speculation. Not dramatically, not defensively, but almost with a calm smile. NASA's Associate Administrator Nikki Fox explained that nothing in the newly processed data showed any signs of technology, construction, structure, or anything even remotely like an alien probe. Instead, she emphasized something simple. 3-eye Atlas behaves every bit like a natural comet. Bright, fuzzy, active, shedding gases and dust as it races through the inner solar system. Still, people remained curious. If everything about it is natural, then what took so long to release the images? Why was everyone waiting for over a month? Part of the answer was the shutdown. Part of it was processing. And part of it was something genuinely impressive. More than 20 NASA missions and telescopes had contributed observations. This wasn't just a Hubble event, or a Webb observation, or a Mars orbiter flyby. This was one of the most diverse interplanetary photography efforts ever done for a single object. The Mars Reconnaissance Orbiter, circling high above the red planet, had captured faint, shimmering views of the comet when it passed about 20 million miles from Mars in early October. MAVEN caught glimpses too. Even the Perseverance rover's cameras were pointed towards space, taking long exposure shots from the Martian surface. Meanwhile, far away, the Lucy spacecraft, designed to study Jupiter's Trojan asteroids, took unexpected detours in its observation schedule to capture the visitor. Psyche, on its long metal world mission, also contributed images. And then there were the legendary giants, the Hubble Space Telescope and the James Webb Space Telescope. With so many eyes watching it, you'd expect the images to show some kind of clear, detailed nucleus, a sharp, rocky core, or maybe an elongated object. But when NASA displayed the frames, something different happened. People realized the truth. Imaging an interstellar object, moving at enormous speed from spacecraft that were never meant to look at it, is unbelievably hard. So the so-called high-resolution images didn't show a solid rock or metallic craft. Instead, they showed a glowing, cloudy sphere, a coma, a fuzzy ball of light. That's what comets usually look like unless a spacecraft flies right up to them. These weren't close-up portraits. These were snapshots taken from millions of miles away. Despite the blur, the science value is massive. Astronomers use the shape, brightness, and behavior of the coma to estimate the size of the nucleus inside. They study the color to understand what chemicals are evaporating. They analyze how sunlight bends through the dust to figure out what elements are hiding in that ancient ice. And because this object comes from another star system entirely, every clue is precious. It's like receiving a tiny piece of a distant world delivered right into our backyard. Throughout the briefing, scientists kept returning to one theme. 3-eye Atlas is behaving exactly like a comet should. It sheds dust. It brightens as it approaches the sun. It forms a tail. It reacts to solar radiation. And nothing about it. No strange acceleration. No metallic reflections. No structural signatures suggests artificial origin. The idea that it was an alien spacecraft had been a viral fantasy, not a scientific argument. And while NASA rarely comments on such rumors, this time they addressed it directly because the speculation had grown too widespread. The comet's journey itself is astonishing. Interstellar objects travel at enormous speed because they're not gravitationally bound to the sun. They just pass through. 43I/Atlas. That meant shooting past Mars in early October, an encounter close enough for several Martian spacecraft to capture its light. Now, as November ends, the comet is racing toward its closest approach to Earth, which will be on December 19th, 2025. Even then, it will remain a safe 170 million miles away, far enough to pose no danger, close enough to allow telescopes to collect valuable data. But the real significance isn't the distance. It's what interstellar objects represent. Think about this. Our solar system formed about 4.6 billion years ago. Other star systems formed around the same time. Over billions of years, comets, asteroids, and icy bodies from other systems get kicked out, thrown into the galaxy by gravitational interactions, rogue planets, stellar winds, or passing stars. Most drift forever in darkness, never meeting anything. But a tiny fraction, an incredibly tiny fraction, end up crossing paths with other star systems. That's what 3I/Atlas is. A messenger from another neighborhood in our galaxy. A frozen time capsule from a place we'll probably never visit. So when NASA says it behaves like a normal comet, that's not boring. That's thrilling. It means the chemistry locked inside it is from an alien solar system. It means the molecules inside its ice formed under a different sun. It means its dust grains carry secrets about processes that happen hundreds of trillions of miles away. Every tiny clue contributes to building a picture of how planetary systems across the galaxy form, evolve, and maybe even create the conditions for life. During the days after the release, scientists all over the world began diving into the new datasets. Teams analyzing spectral signatures. Teams modeling how sunlight reflects off the coma. Teams calculating the comet's mass and shape based on brightness fluctuations. And while the public focused on the fuzzy images, scientists focused on the patterns behind the fuzziness. One particularly interesting question is whether the comet's nucleus is small or medium-sized. Some early estimates place it at just a few hundred meters across. Others suggest it might be closer to a kilometer. But because the coma is so bright, it's difficult to isolate the nucleus without very precise modeling. Webb's infrared observations might help, since infrared light can sometimes reveal deeper layers within the dust cloud. Hubble's ultraviolet data might also show what types of ices are being released. Each telescope captures different wavelengths, and together they create a fuller picture. Meanwhile, the Mars orbiters provided something unexpected, a chance to observe an interstellar object from outside Earth's sky. The atmospheric clarity on Mars, combined with the unique viewing angle, allowed scientists to track the comet's brightness over time in a way they couldn't from Earth alone. That helps determine how active the comet is, how much material it throws into space. And that activity level tells us how fresh or how old its ices are. Interestingly, despite being new to our solar system, 3I/Atlas appears extremely active. That suggests its ices haven't been cooked or dried by too many close passes to other stars. It might have spent billions of years drifting in cold interstellar space, untouched, unchanged. If so, it could be one of the most chemically pristine objects ever observed. As data continues to pour in, NASA is quiet about one thing: predictions. They're not rushing to conclusions. They're not hyping anything. They're doing what science always does: following evidence, interpreting carefully, avoiding certainty until patterns emerge. But one thing they're emphasizing is that interstellar visitors are becoming a new research frontier. First came Oumuamua in 2017, then Comet 2I/Borisov in 2019, and now 3I/Atlas in 2025. 3 visitors in 8 years, after billions of years of silence. That suggests our detection technology is improving, And maybe the galaxy is sending more travelers our way than we ever realized. As for the online world, reactions have been mixed. Some people are amazed, excited, fascinated by the idea of seeing an object from another star system. Others are disappointed that the images didn't show sharp details, as if expecting a sci-fi movie reveal. And then, of course, some still cling to conspiracy theories, insisting NASA is hiding something. But reality doesn't bend to expectations. Reality is often subtler, quieter, but far more meaningful. The truth is, a fuzzy, glowing object captured across millions of miles is still remarkable. The fact that dozens of spacecraft work together, some from Mars, some from deep space, some from Earth orbit, is extremely rare. And the fact that all this was coordinated during a period of limited staffing due to a government shutdown makes it even more impressive. The story of 3I Atlas isn't about aliens or secret probes. It's about how a tiny piece of cosmic ice from another star system can bring together telescopes across the solar system. It's about how science responds when a messenger from deep space appears without warning. It's about humanity looking outward, trying to understand not just what enters our skies, but what it represents about the galaxy. And maybe the most beautiful part is this. In a universe where distances are so massive, timescales so long, and stars so far apart, the fact that something from another sun can drift into our neighborhood, and that we can detect it, study it, and learn from it is almost poetic. It reminds us that the universe is not empty. It's connected, slowly, gently, quietly connected. Before ending the briefing, NASA gave one final reminder. This comet will keep traveling. It will pass Earth safely, then disappear into the darkness once again, heading toward a future star system millions of years from now. We will never see it again. No spacecraft will visit it. No mission will chase it. But the data we collect now, these fuzzy images, these spectral fingerprints, these brightness variations will stay with us. They will help shape our understanding of other worlds for decades. Now, question is, what will the next interstellar visitor look like? Will it be another comet? An asteroid? Something stranger? And will we one day be ready to send a spacecraft to intercept one? Only time and the vast, wandering quiet of space will tell. If you want a quick deep dive into what the images show, make sure to subscribe. This channel